Okay, so let us go ahead and get ourselves started. What we're going to do is keep on pushing this notion of conceptual design and really add a couple more nuances to it of really how we go through and model a building from the top down, really starting with a conceptual form that'll meet some different architectural objectives and really even think about it from an energy performance standpoint. But then we're going to move beyond just sort of thinking about it as a conceptual form and talk about how we transform that from a conceptual form actually into a real building with real objects that we're used to editing in kind of standard Revit ways. So that's really kind of the overall map for what we're doing today. So I'm going to start with just doing some conceptual math modeling stuff, very similar to what we did last time, kind of think about some variations on that theme, and then look a little more deeply into the energy modeling part of it. And then for the second part, we'll go ahead and move into just how we convert these masses into buildings and show you some of the things you need to kind of think about as you're trying to use that approach. Okay, so here's where we're going to get started. I'm going to go ahead and start with the whole notion of the math thing inside again. And as we're going through and working on a project and we're getting started, actually I'll start with manage first. I always like to set the project location first. That's sort of just a good thing because energy modeling is going to need that. So I'll go ahead and choose, for no particular reason, I'm from Kansas City. So I'll search for Kansas City, just so I can get the weather there. Say OK. And again, that's just pulling this latitude and longitude and the weather profile, so it'll help me when I'm doing the analysis. Or actually, let's do something a little bit different. I'm sorry, I think I want to make it a little more extreme. I'm going to have fun when we're here. Oh, there are some environments which are really extreme. For example, have you ever been to Dubai? Dubai is actually kind of a very extreme climate. And I like to sort of think about it because it actually has almost the opposite problem what we have here in the U.S. We always think about worrying about the cold of winter and protecting against that as being a big energy consumer. In a lot of parts of the world, it's actually the heat of the summer that becomes a much bigger issue for thinking about air conditioning. So let's just flip it over a little bit. So once we go ahead and put our location in there, I want to start thinking about this notion of design options that we used in that assignment 2 in a very brief way, kind of thinking about some features for this house that we were putting together, and how you can actually use that even for looking at these conceptual masses. So for example, I could go ahead and create some masses which represent the buildings around the site, and then go through and create some different design options for switching, just different designs that I might have for that site. So, for example, I could create some design options. And just in the main model here, I'll say, let's create an option set. And I'll just kind of rename that to be building shape, something like that. Then within that, I'll go through and create an option. And I'll call it kind of the low flat building. I'll create another option, which is for the tall tower. Maybe I'll create an option for, something that's rotated 180 degrees, whatever it is. Let me take a new option there. I always keep on messing up. Rotated. Let's say 90 degrees. West. Or let me change it counterclockwise. That'll be easier. So I'm just creating some different options. And how we will use this is as follows. Let's close that up. What we often do when we're modeling a site is we'll take the main contextual buildings, the ones that are all around the building that we're going to be designing, and we might make mass models of them just to give us a little bit of site context. We can think about shadows and just how those other buildings might affect them. So I can create a mass, and I could make a bunch of individual buildings or put a bunch together. I'll say existing buildings. Not spelled very well, but I won't worry about that. And I'll go through and, let's say, for example, I was doing something like the SEQ quad. Yeah, that wasn't very good. Whenever I need to draw a straight line, I have trouble doing that. Okay. Yeah, it looks something like this. That's looking pretty good. Let me take that. I'm just going to mirror it. Again, I'm not really doing very good about drawing straight lines today. Let's try this again. Okay, so it's kind of like a Y2E2 in the new building. Oh, maybe I'll put something else in there which is going to represent like the Wong Engineering Center. I'll put some sort of polygon in here. It's an 8-sided polygon. I'll put it in over here. Again, not exactly an accurate model, but it's kind of okay. I can rotate this up, and with these footprints of the adjacent buildings, and we might have generated these footprints by downloading a map or some sort of imagery from Google Earth. I can say, let's create a solid form out of this one. I'm just going to go ahead and create a solid form out of that one. And maybe even a solid form out of this one. And these forms are all independent. I can go through and push and pull them, whatever I want to do. Make them bigger, make them smaller. But all I'm really trying to do is come up with a little bit of context for my new building. Because as we're designing new buildings, we rarely start with just a clean white slate. There's almost always something we're working against. Okay, we'll finish that. Okay, so far so good. We have some existing buildings. Let me see if they cast shadows. I think they will. No, no shadows. Oh well. I was hoping they would. I might have to kind of add some things in there to make them cast shadows. Okay, the idea is if I want to now add another building to this context, a really good way to do it is to actually use design options. So for example, I can say my low flat building. Notice how the other buildings, the context gray out. And now I can start drawing that other form. So I'm going to create an in-place map. This is going to be low flat. What you got?
Yeah, so it went to
Oh, it slept?
screensaver. It slept for a while, but it's back on now.
No worries. So I just drew a profile there for my low flat building. Okay, we'll create a form over here. Actually, I'll make this kind of, what is it? I'm going to make it skinnier. Maybe make it long. And I'm just thinking very high level. I'll make that a form. Okay, this might be my option 1. I'll finish that up. Actually, for option 1, let's go ahead and put some masked floors in there. I should have actually done that up front, shouldn't I? We'll fix it now. We'll add some levels in there. Oh, let me even here. I'm in design option 1. Let me go ahead and switch over to the main model so I can edit those. So I'll make that floor height 15. Again, I'm doing that because in the buildings of the scale of the Y2E2 buildings, there actually are like a fairly tall floor heights to accommodate all the mechanicals. I'll choose that level and I'll put that in here and I'll offset again 15 feet. That was perfect. Maybe I'll put some more floor levels. I'm actually going to put a lot of floor levels in here to allow for that tall tower. I won't use all those floor levels, for all of the designs. Low and flat won't use them all. But I'll just allow that we could theoretically create a building this tall on campus. Or in Dubai. In Dubai, we'd have no problem. Okay, so I'll take low, flat. I could stretch it up a little higher if I want to. But I'm going to choose it, and I'll divide it into all those mat floors. You can go ahead and if you shift, how do I do it? I think it's shift click. Oh, I select and then I just turn one of the checkboxes on. Let's see if I can do that again. If I can turn them off. So if I have them all selected, I can choose one and get them all. Okay. There's my relatively low flat building. Doesn't look so low and flat, does it? I'll push that down a little bit more. I'm only thinking about 3 or 4 stories. Beautiful. That's option 1. He's not looking too bad. Let me switch over to option 2, my tall tower. And notice now the option 1 disappeared. Tall tower is ready to be drawn. We have the context building still in sight. So I can create a mask for that tall tower. And I'm showing you this workflow because this is actually how we do it in industry. It's actually, we create these different options. Often we go through and consider all these different forms. So maybe this one, it'll be kind of like that. Maybe for option 2, I won't go ahead and just draw a simple extrusion. Let me make it a little more interesting. I can draw another box, but I'll put it up at level 14. And the problem is when I try to draw this in 3D, I know I'm going to get myself in trouble. So I'm going to flip it up just so I can see. Okay, and this is more like a little bit of a blend. Okay, let me rotate that back again. So if I want to blend 2 shapes, I choose the 2 profiles. I'm going to control click to get them both. I'll say let's create a solid form out of that. And we'll blend it. So again, there's nothing in particular about these shapes that's all that interesting. These are just different shapes I want to consider. And I'm just making them very different because I want to illustrate the point. So here are my 2 options so far. I have this low flat. I have this tall tower. Okay, let me go ahead and try one that's not just a shape alternative, but it's more of a rotational alternative. For example, I could, let's get that low flat building. I'm just going to copy it to my clipboard right now. That way I can paste it and do a little rotation on it in another one. So I'll say copy it. I'll switch to the rotated and say let's paste it back to the same place. That'll just get it on the ground. Now I can do some rotation of it. Okay, and this is going to test the effect of, what's the difference between having all that long flat face facing the south versus the east-west? And you'll find that's actually a very significant kind of change. What will happen is in climates where we tend to want to collect a lot of heat, we'll often face the long face to the south because we want to capture a lot of sun during the winter and kind of heat things up on the southern side. Or it could be the north if we're down in the southern hemisphere. But by rotating it this way, we're not going to be getting all that heat. So for this very hot weather climate, that might actually be more favorable. Okay, so all we've really done so far is really just created some different options. Okay, and let's just pause there for a second. And I know I've done a lot of stuff in here, but let's kind of just get a sense of how that feels to folks and whether that's kind of making sense of what I'm up to. So what do you think over there for my few folks that are actually in the room? That kind of make sense?
Yeah, what do you got? Yeah, good? Yeah,
Okay.
it's okay.
As long as you have two, that's kind of okay. I just really want to demonstrate the point of having design options and using them this way to kind of evaluate the different forms. Okay. Given these three different options, or these two different options, let's go ahead and just send those off to the energy modeling. So I'll say let's go to the Analyze tab, and I'll turn on the energy modeling. Conceptual energy modeling versus the building element mode. I can say enable that model. Watch what happens. Actually, let me shade it so you see a little bit better. The only model that actually is converted is the one that has the mass floors. So those other ones, those ones that are hanging around just for context, they don't actually get considered for the energy use. So one of the lessons is if you want to consider the energy use of a building, put mass floors in it. If you don't want to consider it, just don't put the mass floors in. So that's really the distinction between whether something's going to get considered or not. Now the cool thing is it probably has already created the energy models for the other variations too. And one of the nice things about sort of doing it this way is as we go through and make changes to the energy model assumptions, it's actually going to apply to all three of those alternatives. So as opposed to creating three separate projects and having to carry those settings across to make sure we're using the same assumptions, design options let us apply the same assumptions to several different alternatives very rapidly. So that's kind of a good thing. Okay, so you have some energy models? Okay, if you have not signed in yet, please go ahead and sign in because we want to be able to basically send this off to the cloud and get some analyses back. So I'm going to start with just the low flat one. I'm going to say, let's run the energy simulation. I'm just going to use the default assumptions right now. I'm going to say, oh, this is my Dubai project. And I'm going to give it a run name. I'm going to call this the low flat building. So this is all based on your Autodesk ID. Let's go ahead and send that away. Looks like something interesting is going on. Okay, next up, we're going to go ahead and send that tall tower off. And again, I will run the energy simulation. Okay, it's also going to be Dubai project. I'm just going to use the existing project, so they'll be together as different alternatives. I'll say tall tower. If you sort of evaluate things separately, that's okay. We can always compare things from what's considered two different projects. This just kind of puts them in the same section of the browser together. Okay. And we'll also look at that rotated 90 degrees. So say, how about running that energy simulation? Again, Dubai project. I'm going to say this rotated 90. So the high level thing, hopefully you'll take away from this first part is that when we're trying to make a design decision and think about what the energy impact might be, we haven't really done a lot of detailed design, but really within 20 minutes, we've actually created 3 different alternatives to take a look at. We're going to get some sort of analysis back that's going to help us decide which of these is the most favorable shape. And that's really the point. It's all about how can we really get answers back very, very quickly to help us make design decisions, right away. Because the decision about whether that building should be rotated 90 degrees or be a tall tower versus low and flat, we want to decide that now. We don't want to decide that 3 months into the project when we do a very detailed analysis. We really want to decide that now where we can make a change and we're not too invested in any design alternatives. So it's all about informing design, bringing information in to help you make quick design decisions that are based on some engineering. So that's really where we're going with it. Okay, so let's go ahead, take a look at the results, see if we can figure out about these 2 or 3 different buildings. Looks like the low flat's done computing. These other ones are still chugging. Just sort of see if we get a sense of, even for one building, what it looks like to build like in Dubai. Because it is very different. So in Dubai, where the maximum temperature seems to be around 104 degrees, and the minimum is about 58, so pretty warm all year round. Okay, we have some assumptions here about the energy cost. Electricity looks pretty cheap. Fuel is pretty expensive. Okay, and that may be a reflection of how much electricity is used there for cooling, where fuel is probably much less common, so we're paying more for it. Okay, so the energy use intensity of this building is about 60 kilobtu. Okay, and that's not actually too bad. When you look at energy use intensities, you'll see all sorts of values and there's targets for what we'd like it to be. You can find buildings that have an energy use intensity of over 100. You're trying to get anywhere lower than 40 or 35 is actually pretty hard. But that's one of those things that we don't really talk about very much. It'd be a really good, interesting measure just to say for all these buildings, what is the EUI? It's kind of a real quick measure of how healthy the building is from a sustainability standpoint. One thing you'll notice about Dubai that's kind of cool is relative to the energy use, there's a very large energy generation potential. So we could actually put quite a bit of photovoltaic on that building to actually reduce the load and lower the overall CO2 footprint of the building. Now, part of what's going on here is this is related to that being a low flat building, so there's a relatively small or large amount of surface area to work with. Oh, coming on down here. These are the potential savings. So let's look at this. It looks like relative to the window glass right now, we have a lot of room that we could go ahead and get better. So this is our baseline right in the center. So the window glass seems to be a pretty high room for improvement here, in that we could potentially save almost 20% of the energy associated with that by making some different assumptions from the default ones that are in there. So we have some room to make some improvement there. Plug loads and lighting efficiencies, we can use better assumptions in there. It looks like the roof insulation, we're already sort of maxed out. The building orientation is looking pretty good. Let's see if that actually pans out when we look at it from an altered orientation. But it actually thinks this south orientation is pretty good. And if I look at the heating load, you see I really don't have much heating at all. In January and in December, I have a little bit of window conductive. But all through the summertime here, I've got some window solar and window conductive. So especially here in the summer months, can you see it gets very high with this deep red bar? That's all about the heat that's actually coming through the window. As opposed to window solar, let me distinguish that. In addition to the heat that comes through the window, there's solar radiation that comes through the window and heats up the floor and then actually gets absorbed inside the building. So there are two different issues. One's just kind of the thermal resistance of the windows. The other is how much solar radiation passes through the windows. And we can get windows that are optimized for each of those different things. So we definitely have room for improvement on the windows. Okay. That's enough to get going on that. Let me do some comparisons. Let me compare these three towers together. See how it works. So low flat, rotated, and tall tower. 60 energy use intensity based on that southern orientation. Rotating it east and west actually made it worse. So that's kind of telling me that the effect of, I think because we have those east and west windows, I'm going to imagine the cooling loads are much worse. Actually, we can sort of see. It's 17 kilowatt hours per square foot if we're facing south. It's 19 kilowatt hours per square foot just by orienting the building differently. So something about just shifting that orientation to east-west versus north-south actually made the electrical use a lot worse. Tall Tower over here, check this out. 84. So compared to our baseline, 20, if I go 24 more, what is that? That's not 50 again. Probably about 45% higher energy use just to be a tall tower versus a low flat building. So for everyone building an architectural monument, tall tower, not to say that's not a bad thing to do, but we should just be cognizant of the fact that there's a real energy cost for doing that. So let me take a look at, in terms of the solar potential, we could get about 151 tons, 171. We have even more photovoltaic potential in the rotating it. But it's interesting. The first one, we use less electricity, but we have less photovoltaic potential. Rotating it east-west did something interesting. It used more electricity, but it also has more photovoltaic potential. But the net is that it's still better to just not use the energy in the first place. And finally over here, it's actually showing a fair amount of photovoltaic potential here. I'm sort of surprised. But this electricity consumption for cooling that building is just really bad. Okay, so you get a lot of sort of interesting information out here. And we have all these funny little reports that kind of show window glass seems to be a very big issue for us. So let's stop and kind of think about how that's computed and really how you get more information. Okay, this whole notion of doing the energy analysis is based on a calculation engine called DOE 2.2, which uses just the surfaces of the building and the thermal conductances through those surfaces to just figure out how much heat's flowing in, how much solar radiation's flowing in. So it just takes surfaces and building properties. Okay, and if you'd like to go through and try variations on a theme, it actually, in the background, is computing some variations on a theme for you. So that's how it's actually figuring out where it thinks the most potential is. Let me kind of show you how you can expose that to yourself so you can actually start controlling that. There's an interface called Green Building Studio, and you can get to it at gbs.autodesk.com, which is really the analysis environment that's behind this. What you're seeing in Revit is really just a subset of what's available, but if you go into gbs.autodesk.com and log in, you could actually go back and see everything in much greater detail. So here's our Dubai project. You'll see it says there's 114 runs. And you might be wondering why that is. Okay, here's what's going on. We sent 3 runs to the project, or to Green Building Studio. Take a look at. For everything we sent, it generated a lot of runs checking out different alternatives for us. So for example, if I open Dubai project and look what's underneath there, there's a base run called rotated 90 degrees CCW. But underneath that, the unit has an energy use intensity of 65.8. But underneath it, it's actually generated all sorts of alternatives. Different efficiencies for the lighting load, for the plug loads, different efficiencies from rotating the building a little bit, which we sort of did manually. Different efficiencies for if we had occupancy sensors, different sensitivities for different types of windows. So in fact, that's what I'll sort of focus on right now. That's the insulated roof. He was pretty good. There's uninsulated frame wall. That was pretty good. But here's these different windows. Quad kryptonite clear, low E glass, low E film skylight, clear windows. I'm just trying to look at all these different options, see if I can find the one that really has the best potential. There's a triple glaze right here. Is that a skylight? That's a skylight. Low E film window, low iron window, low E HP high performance window. Those are skylights. I'm trying to figure out which is the one that actually has so much better potential. Because I know there must be one in here that actually is very, very good. That's my skylights. There's my windows. Looks like actually skylights made a big change, although I'm sort of surprised about that. Double, triple, iron, quad. You can sort of see the difference. The skylight again. Window, window, window. Crypt clear window, 65. That's not helping us very much. Skylights are making a big difference. I'm trying to figure out which is the one that's making the biggest difference. Oh, actually, I should take that back. Yeah. No, it should still be true. I'm just trying to think about like the way to see this. So somewhere within here, in this chart, in the range of values here, says that window glass with DC, window glass, we can get up to a 21% better savings. So let's think about where it is. Lovely film. What's all those with DC? 65, 65. That's a skylight. That's what's sort of confusing me. I see the much better values on the skylight. I know. We got to dig into this. There's actually a lot more in here. Oh, there's tall tower. Okay. But again, these different sort of changes. Yeah, based on that. It's interesting. The skylight numbers always seem to give you the higher change. Always seems about 84.2 for the windows. I know. Got to figure out really what the difference is. Because even in terms of these, you know, I'm not seeing numbers that look like a 21% difference. We'll figure that out. Okay, so hop back out to the project again. Go back to Dubai. And I'll bring up one of those projects. Someone last time actually asked a question about how does this actually compare to eQuest or what's the other one? Energy Plus. So there's all these other simulation tools that people are using to do building analysis, and you might sort of wonder how this all compares. This is all done in something called the DOE 2.2 engine. And that's a perfectly good simulation engine that a lot of people use as a standard. For people who like to work in Energy Plus or eQuest, they can actually download their file as an Energy Plus file or a DOET file that can be read into eQuest. So if people want to go through and continue the analysis in those tools that give you an awful lot of control over really controlling every last aspect of it, they can. And you do it by sort of downloading a file, and then we can save that away and just feed that right into the other analysis tool. So, although a lot of stuff is available in Green Building Studio, it's not the end all. It's really just the beginning of a gateway to a lot of other information. Okay.
So Glenn, there was also a question today about how do you export your Revit model to any of these other softwares like Energy Plus, and so you could do your energy analysis on there.
So if I was wanting to go to Energy Plus, I would actually just do it right here. I would first analyze it in Revit and get it into Green Building Studio.
Okay.
And then from here, we can do the download, and I can save the link as, and it's an IDF file. So I can store that away, and that'll be a file format that Energy Plus can read.
Okay. Okay.
So that's the way. Somebody say new folder with up there. So I'll save that away, and now I can go ahead and pull that into Energy Plus or eQuest, same sort of thing. Save link. That's an INP file.
Okay. Because Dimi made us understand that you could do that from the export button within the Revit environment.
Well, let's go take a look over there. I'll entertain that. Dimi knows a lot more. He does it day in and day out, where I don't. Let's see if we can come out there.
I think someone said IFC, probably.
IFC is a format. IFC is a kind of very international foundation class format. It's good for getting things across to a number of even CAD packages or just BIM modeling packages.
Okay.
So it really depends on which format they'll take.
Okay.
Another format that some people like is GBXML. Although that's more of an Autodesk format. So almost, if you give me a starting point and ending point, I can find some file path that'll connect you. But the idea is you shouldn't have to remodel this twice or 3 times. Because we want to have a workflow where your design decisions kind of keep flowing through.
Yeah. Okay.
So let's just look at a few slight variations of it, and we won't get much deeper than that, because really, at a high level, what we're going to want you to do, actually as part of the next assignment, is really, we're going to give you a program for a building with a certain amount of square footage. We're going to say, hey, we'd like you to come up with a couple of different design alternatives, different shapes, and go through a do this energy analysis and choose really which shape you're going to use for actually turning into a real building. Okay, so it's just going to start with some conceptual shapes, doing that analysis, and moving forward into a real building. So that's where we're going to go with the assignment. Okay, let me go ahead and I'm just going to mess around with the model just a little bit further. In terms of thinking about the model, I've just been putting in all these default assumptions. I really have been playing around with the energy settings. We could change these in terms of glazing percentage, type of construction. This is where you can change things like what kind of glazing is it, and sort of use a different baseline. So the baseline that was comparing to was double pane clear, no coating. I'm betting if we're going to a low E hot climate, low solar heat gain, that would give us a much better glazing profile. That's what I was kind of looking for inside the Green Building Studio interface. But what I want to show you is that you can go through and actually get a little more custom with your buildings. Because even at this conceptual level, you probably have some idea about how you want to put shades on the building, or maybe it's not the same kind of glass everywhere. So even at a very high conceptual level, you can still go through and make some quick changes. Now, this is switched over to something which is showing the mask zone in shades, and I'm going to switch it over so it just says show the form again, or the surface. I'm going to start with the form. So if I wanted to stretch this, or I wanted to start tweaking the shape, I could do that. And just start looking at a slightly different shape. Looks like I can slice the top of the building too. Oh no, it's just a funny angle. Interesting. Boy, does that look weird. It is weird. No, I torque it down. Okay, Mr. Torquey Building. Lead up instead. That feels better. I have no idea why that feels better. That feels better to me. Picked up a floor. Okay. So now what we can do is actually start articulating the shape a little bit differently. So if, for example, I want to start changing the glazing, I could say let's show the surfaces. And for example, if you decided that you really wanted to have a lot of glazing on the first 2 floors, but not necessarily on the upper floors, you can go through and change it like panel by panel. And what I'm going to do is almost like making changes to a curtain wall, where I'm going to tab until I get the panel. That's the glass. That's interesting. I'm trying to change it. It's not fighting. It's fighting me. Let me try the mass zone, see if that'll work. No. It definitely wants to be. I can change an entire surface. I can see that. Like I can get that entire wall. That's kind of okay. And I can say that, let me change it to just some specific settings for that surface. So I can, for example, put shades on that side that are 4 feet deep. Yeah, do something like that. But I'm trying to actually choose that single panel. And I'm wondering why it won't let me do that. So Lottie, as Demi was doing this early today, he was changing it piece by piece, right?
Actually, it didn't cover this now. It shows how to change it.
Okay. Let me just try. I'm such a hardhead. I just refuse to give up.
I think it changed it from the general setting where you could like tweak the percentage.
Yeah, that we can definitely do.
Yeah, that was what it showed us. It didn't change it piece by piece. No.
Try this. That's actually the ability to change the zones. If you have a building that actually has different types of zones. That's the whole surface. I'll figure out at some point why I'm not able to do that. I always hate it when demos don't work. Because I know with enough messing around, we'll get this to work, because it does. But then again, hopefully this is somewhat reassuring to you. When you're struggling with Revit and finding it late at night and you can't get it to do what you want, you aren't the only one. So what is happening here? Conceptual there, values by surface, target percentage. That should be fine. Let me try this. I just want to see if there's any effect that we're introducing just by having it in a design option. That's the whole panel. No. You have to give me a buy on that one. We'll get it figured out, because there's definitely a way that I can do that.
Yeah.
But let's at least then try to make some sense out of what we do have here. So, for example, in this building, we did know that. Let me try this. We did know that the south side was really an area where we were getting an awful lot of sun. So if we were going to try to improve that, we could say, hand that down a little. Shift W. Get that entire panel there. I could go through and put shades on that. So again, that would be by surface. Glass is shaded, and I'll put some big old shades on it. Okay, might also, just on the south side, change the glazing percentage over there. So for example here, I could go through, and as opposed to having all these little windows, I could go through and say, hey, go ahead and make it 80%, very glazing, but then counteract the problem of all that glazing by making sure there's a big shade on there. Actually, shade depth and the depth of the shade should definitely be related to the notion of really how tall the window, because it's all about this notion of just providing shading so the sun's not coming in at the kind of worst heating time. Maybe I'll leave that 40. It'd probably make more sense to do something like this. Smaller shades on the sides, bigger shades in the middle when I put all that glass in. Okay, but again, I don't want to spend too much time or get too deep into the issue of the conceptual modeling, because what's going to happen is pretty quickly you're going to turn this into a real building and articulate it fully, at which point you'll have complete control over this. So again, we'll take this. We'll send it off to the building analysis. Say, shaded south. We'll let that run for just a second. So it'll hang out over there. There go the results. It's doing some computing. Let me just answer some questions as it is going through and doing that. So just at a high level, is this whole notion of trying to figure out just, what sort of energy use intensity would be predicted for these different shapes. How's that sort of resonating with you as a workflow? Do you like the idea of being able to kind of get that feedback and kind of use it as part of your design decision?
Yeah.
It's
kind of making sense about why we do it. We can do it at this high level.
Seems like Harry has a question.
Yeah.
Someone has a question. Huh?
Last question.
Okay.
So now that you're done with the form, the shape, let's say you like the energy efficiency of this specific shape.
Yeah.
So how do you pretty much draw the same shape again and you draw the walls and floor like you did in the last
okay.
5 weeks, or is there like a trick or button you can do?
Okay.
And also another question is, do the existing buildings affect our energy analysis in any way?
Okay. So Glenn, so you want me to repeat the question?
Sure. It started with once you found a good shape.
Yeah.
Then how do you turn that into a building?
Yeah, exactly. How do you turn that into a building? And then the second question was about. The second question was about energy analysis.
So we draw the existing buildings. See the existing buildings. Do they affect the energy analysis in any way?
Yeah. So the second building, the changes you made, did they affect the energy analysis in any way?
The changes in humidity.
Okay. Okay. I think you can actually hear it from there.
Well, no, go ahead and tell me what the change is. Changing what?
Changing what?
No, I was asking. So,
Try to get this.
so you drew up 4 forms there, and one of them is the one you've been working with. And the other 3 are there's the 2 L shapes and the.
Oh, okay. Do they affect the analysis in any way?
Yeah.
Oh, okay. The other ones in the other conceptual models that you made in your design, does it affect the analysis in any way?
Oh no, they're the other forms, the ones that don't have color.
Yeah, the ones that don't have color or any. Yeah.
No, they're not being considered. They're really there just for context. They're inactive.
Oh, okay.
Yeah, so if we would put a mass floor in them, then it would consider that area also as part of the calculation. So usually I put them in there just to sort of understand what's around or hopefully to cast shadows.
So this might be beyond the scope of this class, but so if you were to really go into detail on modeling the energy efficiency of a building, let's say you're building it in the middle of downtown, but you have to draw up forms with the floors of the buildings right around the building you want to build.
Mm.
So if the building's downtown and there's a lot of other buildings around it,
Yeah.
Yeah.
Will that affect the energy analysis?
Yeah, that's the question.
Yeah, would you have to model?
Would you have to model the
other
surrounding buildings and put in floors there?
From the standpoint of wanting to understand the effect of the shade that the other buildings are casting and cutting out some of the sun, you'd want to include the form just so that shade would basically block the sun, block the solar radiation. You don't. It's really just at that level. There's not a notion of like the other buildings are actually releasing heat also, so we can sort of think about the overall microclimate and whether that's being heated up by the building. But at least the notion of the shading provided by the other buildings, or the shading from the wind, or the shielding from the wind, that's considered.
Okay.
Yeah, so it's really pretty cool. In fact, even there's some other tools if you really go further, where you choose whether it's an urban environment or a rural environment or a suburban environment, because it does make a big difference in terms of tempering the weather profile. Cities, because of all the concrete, all the built mass that absorbs energy and re-radiates it throughout the day and night, tend to be, they're flatter, they're more moderate, where if we're out in a very rural environment on a hilltop, then you have it's a very weather extreme. Okay, so let's go ahead. We're going to talk about the issue of converting this into the building in a second. Let me go ahead and just do this shaded south and see what made a difference, if that made a difference. So hang on. Do some comparison. So you have the original building and the shaded south building. So check that out. Just by putting shades on the south, even though I went through and added a lot of glass on the south side, we could actually cut the energy use intensity by, what is that? It's not quite 10. Oh, what is that? It's like 8% or something like that. Or no, it's more than that. Like 15% or something. That's actually pretty good. So again, the point that this is really trying to drive home is that simple little measures can actually make a very big impact. So as opposed to thinking about having a bigger HVAC system or some very costly change, just thinking about maybe putting a more interesting facade on the south side that has some shading could really save you more energy than increasing the insulation in all the walls. Or putting a very much more expensive window glazing in there or something. Okay, let's go ahead and pause right there. That's kind of where I wanted to go with the energy analysis. I want to shift into the notion of just making this into a building and some of the tricks and traps in terms of doing that.